But what about emissions that are already released? Can we capture carbon, store it, and still run the economy? India has committed to achieving net zero emissions by 2070. At the same time, India's energy demand is continuously increasing due to economic growth, industrial expansion, and rising consumption. So, the real change and the real challenge is not choosing between renewable energy and fossil fuels. This is not actual real challenge, that is choosing between renewable energy and fossil fuels. Then what is the real challenge? The real challenge is understanding how to reduce emissions without compromising energy availability. This is the actual challenge. This is the real challenge. Reducing emissions without compromising energy availability. So, UPSC is not testing energy sources here. It is testing trade-offs within the systems. UPSC not testing energy sources. It is testing system control. It is testing trade-offs within systems. Every solution in the energy sector creates a new problem. Renewable energy creates intermittency. Fossil fuels create emissions. Battery storage creates mineral dependency. Nuclear energy raises concerns of safety and waste management. Like this, every solution in the energy sector creates a new problem. So, therefore, what we are dealing with is not a single solution, but a system of interconnected choices. System of interconnected choices. System of interconnected choices. So, let us begin with carbon capture, utilization, and storage. Commonly referred to as CCUS. CCUS means carbon capture, utilization, and storage. CCUS involves capturing carbon dioxide emissions from industrial processes, capturing, then and transporting it and either storing it underground or using it in other applications. Let me simplify this easily. CCUS process is simple as that. Capturing carbon dioxide emissions from industrial processes. First capture, then compression. After either transporting it or storing it underground or using it in other applications like utilization. So it is important to understand that CCUS, that is carbon capture, utilization, and storage, does not reduce emissions at the source. Then what? Instead, it manages emissions after they have already been produced. So CCUS is not prevention, it is damage control. Manages emissions after production, not prevention. It is damage control. So the process typically involves three stages. First, carbon dioxide is captured from sources such as power plants, cement industries, and steel production units, etc. Then second, it is transported through pipelines or ships. And then third, it is stored in geological formations such as depleted oil fields or saline aquifers. Saline aquifers. In addition to storage, carbon dioxide can also be utilized. It can be used for enhanced oil recovery, chemical production, and the manufacturing of building materials. So utilization or storage. This leads to an important conceptual point, that is CCUS is not limited to storage. It also includes utilization. That is the important conceptual point here is. Now consider this from an examination perspective. We have to. If a statement suggests that CCUS only stores carbon dioxide, the statement should be eliminated because it ignores the utilization component. So it is also utilized. Let us now examine where CCUS is actually relevant. It is most useful in sectors where it is difficult to replace fossil fuels through electrification or renewable energy. These sectors are referred to as hard to abate sectors, such as steel and cement industries. Hard to abate sectors means this is most useful in sectors, but difficulty is replacing fossil fuels. Difficulty. That is why these are called hard to abate sectors. Now we come to a deeper level of understanding. CCUS allows the continued use of fossil fuels while reducing net emissions. So it is dealing with after production of emissions, then it converted and captured net emissions, reducing net emissions. Therefore, it does not reduce dependence on fossil fuels. Please mind this point. Therefore, it does not reduce dependence on fossil fuels. CCUS solves emissions, but it sustains fossil fuel systems. CCUS also has limitations. It is expensive, energy intensive, and carries risks associated with long-term storage. Additionally, it can delay the transition towards renewable energy if over relied upon. So we have to think about limitations also, not only uses or utilization or storage. Few limitations like expensive, energy intensive, carries risk associated with long-term storage. These are. So CCUS is a transition tool, not a final solution. This has to be remember all the time. This has to be remember all the time. This is the thing about CCUS. Let us now move to hydrogen as part of the energy transition system. Hydrogen, what is the hydrogen system? We have to learn. Hydrogen is often described as a clean fuel in the future. However, it is essential to understand its fundamental nature. Hydrogen is not an energy source here, it is an energy carrier. We are moving to hydrogen, that is energy carrier. Hydrogen does not reduce or produce energy, it stores and transports energy. It is behaving like an energy carrier, not energy source here. Hydrogen is typically produced through electrolysis, where water is split into hydrogen and oxygen using electricity. If this electricity is derived from renewable sources, the hydrogen produced is referred to as green hydrogen. This highlights an important point, that is, hydrogen depends on another energy source for its production. Have to think once. Now let us consider its role. What is this? What is its role? Why it is most important? Rather than it is using another energy source, it produce production. Its production. Hydrogen is particularly useful in sectors where direct electrification is inefficient or impractical. These include sectors like steel manufacturing and fertilizer production and certain segments of heavy transport. So, in these sectors, hydrogen can replace fossil fuels and reduce emissions. However, it cannot replace renewable energy sources such as solar or wind. This is because hydrogen itself is produced using these energy sources. That is why, therefore, hydrogen complements renewable energy rather than replacing it. Hydrogen is not universal, it is selective in its application. Like that, hydrogen also has its limitations. Its production in energy intensive. Its production is energy intensive. Infrastructure requirements are significant for that, and costs are currently high. These are the limitations here for hydrogen. Therefore, hydrogen can produce fossil fuel used in specific sector, but it cannot eliminate fossil fuels entirely. Now connect this with CCUS. CCUS manages emissions from fossil fuels, while hydrogen aims to replace fossil fuels in certain applications. Understanding this distinction is essential for correctly interpreting system based questions. So CCUS manages what? Emissions from fossil fuels, while hydrogen aims to replace fossil fuels in certain applications. So this is the thing actually here. So let us now we move to hydrogen with MCQs. Evaluate this logically. The first statement is incorrect because, what is that first statement? With reference to hydrogen energy, consider the following statements. Hydrogen can act as primary source of energy in place of renewable energy. Green hydrogen production depends on renewable electricity. Hydrogen can replace fossil fuels in certain industrial process. The first statement is incorrect because hydrogen depends on another energy source for its production. Therefore, it cannot replace renewable energy. The second statement is correct because green hydrogen is produced using renewable electricity through electrolysis. And the third statement is also correct because hydrogen can replace fossil fuels in sectors such as steel and fertilizers. Therefore, the correct answer is 2 and 3 only. This is the key distinction. Hydrogen complements renewable energy, it does not replace it. Hydrogen complements renewable energy, it does not replace it. So, next we are moving to battery storage. Let us now examine battery storage within the energy transition system. What is the battery storage? Renewable energy sources such as solar, wind are intermittent in nature. That is the thing here. They do not produce energy continuously due to several reasons. Battery energy storage systems are designed to store excess energy generated during periods of availability and release it when required. This point is most important. Battery energy storage systems are designed to store excess energy generated during periods of availability and release it when required. This is the actual working of battery storages. Batteries do not create energy, they manage time within the energy systems. They storage, they store the energy, not create the energy. This makes batteries essential for integrating renewable energy into the grid. However, it is important to recognize their limitations. Few limitations are there with them. What is the limitation? Batteries are expensive, rely on critical minerals such as lithium and cobalt, and are not suitable for long duration energy supply. Therefore, while batteries reduce variability, therefore, while batteries reduce variability, they do not ensure complete stability of the energy system. From an examination perspective, if a statement suggests that battery storage generates electricity, it should be eliminated because batteries only store and release energy, not generation. Now consider the interaction. Battery storage supports renewable energy, but it cannot replace baseload power sources. Let us now examine battery storage. Batteries store excess energy and release it when required. They do not generate electricity. Batteries manage time within the energy system. Now consider this. With reference to battery storage system, consider the following statements. They generate electricity during peak demand. They store surplus renewable energy. They help reduce intermittency of renewable energy. These are the three statements. Now we have to evaluate this. The first statement is incorrect because batteries do not generate electricity. They only release stored energy. The second statement is correct. The third statement is also correct because storage reduces variability. Therefore, the correct answer is 2 and 3 only. Now we are moving to nuclear energy ensuring stability. Nuclear energy is not classified as renewable, but it is a low carbon source of energy. Its most important feature is that it provides continuous and stable power supply. Provides continuous and stable power supply. That's why nuclear energy is most important. 24 by 7 stable energy, carbon free baseload. Let me repeat it again. Nuclear energy is not classified as renewable, but it is a low carbon source of energy. Its most important feature is that it provides continuous and stable power supply. Nuclear energy is not renewable, but it is reliable. This continuous supply is referred to as baseload power. Nuclear energy plays a critical role in stabilizing the energy grid, especially when renewable energy penetration increases. In the Indian context, nuclear energy is developed through a three-stage program involving uranium, plutonium, and thorium. This reflects both energy strategy and resource utilization. Now consider the interaction between nuclear energy and battery storage. Batteries store energy for short durations, while nuclear energy provides long-term stable power. Therefore, battery storage and nuclear energy perform complementary roles rather than identical ones. From an examination perspective, nuclear energy should not be confused with renewable energy, but it should be recognized as a stable low carbon source. Let us now consider nuclear energy. Nuclear energy provides continuous and stable power known as baseload power. That is very much simple. Is not renewable, you know, it is reliable. So now consider these few statements with reference to nuclear energy. Consider the following statements. Statement number one is nuclear energy is classified as renewable energy. Statement number two is it provides continuous baseload power. Third statement is India's nuclear program aims to utilize thorium in later stages. Now we have to evaluate this. The first statement is incorrect because nuclear energy is not renewable. The second statement is correct. The third statement is also correct because of India's three-stage nuclear program. You already know. Therefore, correct answer is 2 and 3 only. Let us now integrate the entire system. CCUS manages emissions from existing fossil fuel systems. Hydrogen replaces fossil fuels in specific sectors like fertilizers, steel. Battery storage manages the variability of renewable energy. Then nuclear energy ensures stability of energy grid, continuous power, 24 by 7, baseload power. However, UPSC will not ask these roles directly. Then what? Instead, it will test how these components interact with each other. That is the thing here. You have to focus. For example, it may test whether one technology can replace another or whether one reduces the need for another. Like these type of interactions they may ask in UPSC civil services examination as far as prelims is concerned. UPSC tests interaction within the system, not isolated components. This has to be keep it in your mind always. UPSC tests interactions within the systems, not isolated components. Now let us test the entire system with few MCQs. With reference to energy transition systems, consider the following statements. Expansion of nuclear energy can reduce, this is the first statement. Expansion of nuclear energy can reduce dependence on battery storage in certain contexts. Statement number two is hydrogen can replace fossil fuels across all sectors of the economy. Statement number three is CCUS carbon capture, utilization and storage can enable continued use of fossil fuels while reducing emissions. Now think carefully, the first statement is correct in the context because nuclear provides stable power which can reduce storage requirements. That is the important thing here compared to battery storage. The second statement is incorrect because hydrogen cannot replace fossil fuels in all sectors, few sectors only, steel and fertilizers. The third statement is correct because CCUS allows continued fossil fuel use with emissions management. Therefore, correct answer is 1 and 3 only. So, at this level, there are no absolute answers. They are only context based answers. A statement may appear correct in one context and incorrect in another. So, UPSC does not reward what is absolutely correct. It rewards what is correct with context. So, that's the way you have to eliminate the wrong options. If you see topics, you will definitely you will struggle. If you system, if you see systems, you will solve. I'm Niranjan Ankilla, founder Metis IAS Academy. I will see you in the next master class. If you approach this exam through isolated topics, you will struggle always. If you approach it through systems interaction, you will gain control. Thank you.